All right, pre-algebra 12.6, talking about some very special forms of right triangles today, okay? So we're starting off talking about triangle ABC, which is an isosceles right triangle. We know that because these two sides are marked with one line, which tells us that they are equal to each other. The angles opposite the equal sides are equal. So angle A is going to be equal to angle B. The sum of the angles of any triangle is 180 degrees, and we know that this one is 90 degrees. So if angle C is 90, that means A and B together must be 90. If they are equal to each other, then we divide that 90 by 2 to figure out how much each one of those angles are, and that means they are each 45 degrees. In the figure below, this triangle right here, each leg is 1 unit and the hypotenuse is represented as C. According to the Pythagorean theorem, the length of C would be equal to the square root of 2, right? C squared would be equal to 1 squared plus 1 squared. So C squared is equal to 1 plus 1. C squared is equal to 2. How do we figure out what C is? We take the square root of both sides, and C is equal to the square root of 2. Every isosceles right triangle is also called a 45-45 right triangle, okay? The sides of similar triangles are proportional. So if you know the length of one side of such a triangle, you can find the missing lengths of the other two sides. If A is the length of a leg, and C is the length of a hypotenuse, then the following proportion is true. A over 1 is equal to C over the square root of 2. Cross multiply, and you get 1 times C is equal to A times the square root of 2. C, the hypotenuse, is then equal to A times the square root of 2. And remember that in an isosceles right triangle, A would refer to both of the legs because the legs are the same length because it's an isosceles right triangle. So the legs are the same length, all right? So in every 45-45 right triangle or isosceles right triangle, okay, if each leg of a 45-45 right triangle is A units long, then the hypotenuse is A square root of 2 units long for every single isosceles right triangle, or what we also call a 45-45 right triangle. No matter what A is, no matter what it is, the hypotenuse is A times the square root of 2, okay? That also means that if the hypotenuse is A times the square root of 2, and you know that the hypotenuse is the square root of 2, how do you figure out the length of the side? You just divide by the square root of 2, and you know that then the length is A, okay? So example number 1 says find the length of the hypotenuse in the 45-45 right triangle. So here we have a 45-45 right triangle. The lengths of the legs are 3, okay, 3 and 3. And because we were told, okay, no matter what, in every right triangle, every 45-45 right triangle or isosceles right triangle, the legs are A and the hypotenuse is A square root of 2. So if the leg of this triangle in example number 1 is 3, then the hypotenuse is simply 3 times the square root of 2. That's it. That's all you have to do. I didn't have to do 3 squared plus 3 squared is equal to C squared and go through that whole thing. You would get to 3 root 2 if you did that. That is what you would end up with. But we can just use this really nice simple rule that we can memorize, hint, 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 that we can memorize to solve for the lengths of either the legs or the hypotenuse in a 45-45 right triangle. Now, example number 2 says find the lengths of the legs in this 45, 45 right triangle. So we're given that the hypotenuse is 5 root 2, okay? 5 root 2. In a 45, 45 right triangle, the length of the hypotenuse is always a root 2, right? So what is A? A is 5. So the length of the leg in this triangle is 5. It's that simple. I didn't have to do anything else. I just recognize this relationship and I know that the length of the leg is A. Okay? Box skill check number 1, find the lengths of the legs in these triangles. Okay? So, number 1, we're told we have a hypotenuse of 10 root 2. Hypotenuse is equal to A root 2. Leg is equal to A. So in number 1, what is the length of the leg? It's 10. Okay. Number 2, what's the length of the leg? It's 3. Okay. Find the length of the hypotenuse in the following 45, 45 right triangle. We have legs of 8. Okay. So if the leg is 8, then the hypotenuse is 8 root 2 because it's just A root 2. Legs of 12, 12 root 2. Do not make this harder than it is. It really is this simple, okay? Then we have another special kind of right triangle, and it is an equilateral triangle. What do we know about an equilateral triangle? We know that all sides are the same length and all angles are the same measure. Okay, since the sum of the angle measures in any triangle is 180 degrees, if all 3 of the angles are the exact same, then they are equal to 60 degrees because 180 divided by 3 is 60. If you drop a perpendicular from the vertex of an equilateral triangle, like so, here is dropping a perpendicular from the vertex. That means we're taking a straight line right down from the vertex to the opposite side, okay? That perpendicular will bisect both the opposite side and the angle. Bisect means to cut perfectly in half. So if we cut this angle right here, which was 60 degrees right here, if we cut a 60-degree angle perfectly in half, we get 2 30-degree angles, okay? And then down here, we have perfectly bisected this leg down here, so the lengths of each of those legs are equal. Now, because we've dropped that perpendicular, we've made 2 right triangles. Here we have a right angle, here we have a right angle. We know that this angle is 60, and this angle right here is 30, right? Okay, 30. These triangles are called 30, 60, 90 right triangles, okay? 30, 60, 90, where we have a 30-degree angle, a 60-degree angle, and a right angle, okay? In 30, 60 right triangles, the side opposite the 30-degree angle, okay, so the side opposite the 30-degree angle, this right here is the side opposite my 30-degree angle, is 1/2 of the length of the hypotenuse. Where's the hypotenuse? The hypotenuse is the diagonal from the 90-degree angle. So here is my hypotenuse. So the side opposite the 30-degree angle is half of the hypotenuse. So this side is A, this side is 2A, because A is 1/2 of 2A. That's why this is A, this is 2A. Applying the Pythagorean theorem, you can find the length of the long leg. Here's the long leg. Probably should switch to another color so you guys can see that. Here is the long leg, okay? When we apply the Pythagorean theorem, you can find the length of the long leg in a 30, 60, 90, okay? What they've done is here's a squared, okay? Here's x squared, there's the long leg, and we've already said If the side opposite the 30-degree angle is A, the hypotenuse is 2A. So here we've plugged in 2A for the hypotenuse. So a squared plus x squared is equal to 2a squared. 2a squared is 2 squared times a squared. So that is 4a squared. So now we have a squared plus x squared is equal to 4a squared. Subtract a squared from both sides and you get x squared is equal to 3a squared. Take the square root of both sides and you get x is equal to the square root of 3a squared. Well, the square root of a squared is a, and the square root of 3 is 3. So a root 3. We've now determined that the length of the long leg x is a root 3. Okay, so in a 45-45 right triangle or an isosceles right triangle or 45-45-90 triangle, okay, we know that the leg is a and the hypotenuse is a times the square root of 2. Now we have another rule for a special kind of triangle, and that triangle is a 30-60 right triangle, okay, a 30-60 right triangle. If the short leg of a 30-60 right triangle is A, and the short leg is always the side opposite the 30-degree angle, so the short leg is A, okay, then the long leg is A times the square root of 3, and the hypotenuse is 2 times A. So if we know any one of those 3 lengths, we can figure out the length of the other legs or the hypotenuse, okay? So example number 3, find the missing lengths x and y in this triangle. It is a 30-60 right triangle, okay? The side opposite the 30-degree angle is 4, okay? The side opposite of the 30-degree angle is always our short leg. Our short leg is A. Our long leg, the side opposite the 60-degree angle, is A root 3. And the hypotenuse is always 2A. So take a look at this angle. Here's our 30-degree angle. The side opposite the 30-degree angle is our short leg. That is 4. So A is 4. So our long leg, y, because it's opposite the 60-degree angle, is a square root of 3. So that is 4 square root of 3. The hypotenuse, the side opposite, so the long leg in our triangle is marked y. So y is 4 square root of 3. The hypotenuse, x, opposite the right angle, is 2 times a. So that is 2 times 4, which is 8. So x is 8 and y is 4 square root of 3. And I did not have to use the Pythagorean theorem to figure it out. Okay? Find the short leg and the hypotenuse of a 30-60 right triangle whose long leg is 6 root 3. Draw a picture. Okay, 90 degrees. So here's my hypotenuse. Hypotenuse is A. Hypotenuse is 2A. Here's my 60. Okay, the side opposite my 60-degree angle is my long leg. That is A square root of 3. Here's my 30-degree angle. The side opposite my 30-degree angle, my short leg is A. All right, plug in what we know. We know that the long leg is 6 root 3. Long leg, which is A square root of 3, we're given as 6 square root of 3. So my short leg is equal to A. What's A? 6. And my hypotenuse is equal to 2A. 2 times A is 6 is 12. Okay, that's simple. Example number 5. Find the long leg and the short leg of a 30-60 right whose hypotenuse is 9. Draw another picture. 90, 60, 30. Okay, hypotenuse is 9. So the hypotenuse is 2a. That's equal to 9. So what is a? Well, if 2a is 9, okay, what is a? Short leg is equal to a. Well, 2a is equal to 9. Solve for a by dividing by 2 on both sides. So a is equal to 9 divided by 2, which is 4.5. Okay, 4.5. Long leg is equal to a times the square root of 3. 4.5 times the square root of 3. That's it. That's literally it. Okay? Skill check number 2. Find the other two sides in the following 30, 60, 90 right triangles. 30 degrees here is equal to x. So here is our short leg. Okay? Here's our long leg. And here's our hypotenuse. Okay? Short leg is equal to a. Long leg is equal to a root 3a. So if our long leg is 5 root 3, a is 5. Hypotenuse is equal to 2a. 2 times 5 is 10. Okay? So x is 5 and y is 10. Number 2, here we have our 30-degree angle. Okay? So here's a across. Okay? Y is across from our 60-degree angle, so that's a root 3, that's our long leg, and x is our hypotenuse, which is 2a. So if a is 3, our hypotenuse, x, is equal to 2 times 3 is equal to 6, okay, and y is equal to a root 3, so a is 3, 3, square root of 3, okay. Example number 3, x is across from our 30-degree angle, so that's our a. Y is across from our 60-degree angle, that's our a root 3. And 8 is across from our, or opposite, opposite, I should use the word opposite, that's more clear. 8 is opposite the 90-degree angle, so that is 2a, okay? So if 2a is equal to 8, a is equal to 4, okay? So x is equal to 4. Y is equal to a times the square root of 3, 4 root 3. Okay? If I have a short leg of 9, okay, short leg is a, right? So long is a root 3. So the long leg is 9 square root of 3. And the hypotenuse is 2a. 2 times 9 is 18. If I have a hypotenuse of 15 in number 5, okay, hypotenuse is 2a. So to figure out a, I divide 15 by 2, which means my short leg, which is a, is equal to 15 divided by 2, or 7.5. And my long leg is a square root of 3. So that is 7.5 square root of 3. Number 6, if I have a long leg of 14 square root of 3, long leg is a root 3, which means a is 14. So my short leg is 14, and my hypotenuse is 2 times a, so 2 times 14 is 28. That is this lesson, applying the rules for 45-45 right triangles and 30-60-90 right triangles. You will have to have these rules memorized.